Yeah, I just want to say welcome everybody to our second webinar. We've got Ken back to present on excavation, footings, foundation, radon, and drainage. Yeah, I just asked that everybody mute their microphones and maybe turn off your camera just so that we don't have any bandwidth issues here, and I'll do the same. And welcome back, Ken.
Thank you, Peter. You can see my slide deck up on the screen, okay?
Yep.
Okay, great. Good morning, everybody, and welcome back for those who were able to attend our first session last week. We're going to continue on with some general code education and some information related to what's going on with the city. As Peter mentioned, we're going to keep your microphones off, your videos off for bandwidth. We'll be keeping track of who's attending. The presentation will be recorded, and then we'll be sending an updated PDF of the slide deck to Peter at the end of the week. If any questions on that, I can alter it as we go. If you have any specific questions or comments related to today's session, I have a lot of slide decks. I've been playing around with it the last few days, adding and subtracting. So if you feel like we will lose a little bit of continuity in some of the subject matters and you'd like to know more, just reach out to me and I'll put a bit more information together on a certain subject. This workshop series is a commitment by the city. The city, had brought in a consultant. They brought in myself. We did that great workshop in December, and the city's just wanting to continue to improve their processes. I believe there's a lot of work being done right now in the online permitting process and bringing that up to speed. So there's lots of things the city is doing, and this is one way that the city is reaching out to the building community just to get a better understanding of codes and the permit process to help speed things up. I don't cover everything in the code or everything in the code section. So again, just presenting some ideas and getting yourself familiar with the different code sections really related to in-ground items here in the code. And yeah, they're not super exhaustive, but I hope you can have a very good takeaway and understanding of what's going on. This is the second series, excavation, footing, foundations, radon, and drainage. I was going to add a few more in there for underground structural items, but just don't think we'll have enough time. And then, I got to change this date. Feb 5th is actually Feb 12th. It'll be the framing. I'm also going to include some items regarding the permanent wood foundation. So I'm just going to touch on a little bit today, but I'm going to focus in another possible area of a foundation system. And as we roll along, all these workshops will lead into a guide to develop in March. So anything related to applying for a permit for a Part 9, the permit review process, and then moving into inspections, we're hoping to develop, including some example drawings, improvements. So one item that I came across while doing some research is within the illustrated guide of the code, the older version. They really break this code out into 5 basic sections. So the use and egress, fire protection, building structure, environmental separation, and building service. I find this helpful when thinking about presenting, or if you're thinking about where these kind of fit in to the big picture. So we have, we're going to go over some definitions, material systems, and structural requirements, excavation, footings, and foundations, and then some the damp proofing. We won't unfortunately get onto floors on ground and crawl spaces, but they're all in that section. So yeah, we're going to stick in these 2 areas here. City Whitehorse, I had mentioned, are continuing to try to make improvements, and what they're producing, not only going to be posting these videos online for your viewing, but they just recently brought out 3 new bulletins, more to do with some of the issues regarding structural requirements. So the big ticket item, we've been talking about for a while is trusses, and then the permanent wood foundations and cast in place, mostly revolving when an engineer is involved. So I put a link on here, but you can at any time go onto the city website and check those out. So today, this session has been developed to assist the building industry. Just to get a better understanding of minimum drawing requirements, because better drawings mean quicker review times, less, shaking your head as a building official trying to figure out what's going on, and trying not to write so many notes on drawing or asking for revisions. Going to just touch on some of the inspection requirements as we get into some of these code subject matter. A reminder on site safety and reducing the negative impacts to neighboring properties, touching on when a professional as well. So we'll look at some of the information from the bulletins and some of the previous information that Richard has been talking about last year, moving into this year, as well as within the code and the bylaws. And these specific items within the code itself of 9394, the excavations, the dam proofing, the drainage, and the footing and foundations. When developing this session and just my own education and process, again, I'm a BC guy. Been working with BC codes for 30 years. I've been getting up to speed the last several months on the national code, which is harmonizing with the BC code, but there is still a lot of interesting differences. So I've had to catch myself a few points, and it was nice that I got some really great information coming out of the workshops and being able to stylize these. But these are the 3 points of references that I'll be kind of drilling into today. I have mentioned in the past that at the workshop in our last session that I'll be developing a bit of a case sample house. So as I develop the drawings and figure out some items related to code and very unique items within the city of Whitehorse because of its seasonal challenges, I'm going to be basing some of my material today and moving forward in the next sessions on a two-story over a basement. We're going to be using Whitehorse as a climatic zone, soil bearing capacity. So trying to keep it on the lower end. So because and I'll explain that a little bit more as we go through the slides. Standard load bearing for a single family home. So nothing crazy. Pretty standard two-story framed home. Dimensional lumber, preserved treated wood as applicable down in the foundation system, the permanent wood foundation. And we're going to be putting those on a concrete footing with a concrete slab. We could look at suspended floor, but for just probably these sessions, we'll look at more standard. And then strip and pad footings. And then I'd also like to touch on some flat insulating concrete form work. If you have an opportunity to just go into your chat, and it's going to put my chat on so I can see. If you can just let me know, what part of the building industry that you represent, whether you're a builder, a tradesperson, a designer, registered professional, supplier. If you're a supplier of building materials, it'd be great to know. So feel free to put those in. And again, if you have a question, I'm trying to, on one side of my head, trying to watch the chat if you have a specific questions. Last week we went over the permitting process, and there's been a slight change over the last few months where before you have to get a DP drawing review done as part of, say, a single family project, but now the city has launched into a parallel review process. So you have a DP and a building permit application moving through the process at the same time. There's some pros and cons to that. And a lot of it is regarding internal and external communication as revisions and changes are made as you're developing it. But by the time your development permit review is completed, the building permit should also be ready to go. So hopefully that'll speed your journey up and have a little more consistency moving forward with the team members that you're working with here at the city. A lot of it relies on, and we're gonna, again, a lot really important subject matter today is what you're doing with the site plan and the lot grading. So just being really familiar in providing, getting your lot grading plan for new subdivisions or getting the survey done, particularly for infill developments. And when you're thinking of infill developments, you want to think past those property lines. You want to think about 5 feet away, because whatever you're doing on an infill, especially with excavations, it could have really negative impact to the neighboring properties and city properties and infrastructure. So just being very mindful that, when they ask you for all these things, that you get it in there and get the application form all filled out and send it in, because it's really a very critical inspection or a review process. When it comes to the building permit application, again, make sure it's all filled out. The required documents are provided at the time of application, and the city will be pushing back on incomplete applications just to speed up the process. They'll be more than happy to have a look at it, provide a deficiency checklist, and provide that for you as an applicant to come back. But if people are consistently coming in with incomplete and they're consistently needing to spend time to deal with that, they're slowing the whole process down as a city, and it's not fair to everybody else in the process. And when you're looking at separate types of applications, or garden suites, living units, living suites that both the DP and BP might have these additional informations to provide, refer to the city's drawing checklist. So in that building permit package at the back that you'll see online or a hard copy, it's really important to follow those. And again, that's not covering everything. And I'm going to touch on these lists here in the next few slides. But what you're wanting to do is be able, as a designer, as a builder developer, especially thinking about, the building as a whole, you may have heard the term of integrated plan development, where you're getting all your tradespeople, everybody together as you're developing the permit set in order to get everything figured out and move it forward. But it's really important on these drawings to provide enough information to show substantial compliance with the National Building Code. And if you're just putting a lot of general notes without specifics, and as we move into the next few sessions, we'll be developing the drawings from the information that's on the city's website. And there's some really great examples that the city is able to look at, and we'll be able to reach out to a few designers, hopefully, and work on a few of these. But again, should provide enough information to again show substantial compliance to the code and city regulations, which will reduce turnaround times. So on this session, we're just going to touch on the site plan, foundation, and the cross section. So again, the development permit and the building permit drawings for site plan and lot grading should match. So hopefully it'll be a bit more consistent now that it's a parallel review for the smaller projects. Set to a scale, provide this, the street and property information, put all your zoning requirements, your setbacks. It's really important, particularly your cantilevers. When you're looking at infill, again, thinking past the property lines, you want to look at some landscaping structures that may be affected during your excavation and landscaping on your end. It'll likely start triggering some thought about when professionals are involved. Driveway dimensions indicate portions of building renovated. So again, when you're looking at demo, reno, put all that information on there, including accessory buildings, show all your easements and rights of ways, because that's really important to develop your building footprint, your location of utilities and any upgrades. And if you're on a steep slope, again, making sure you're working with probably your surveyor to figure out what you're doing with your contouring your property there. And your retaining can be quite problematic with the frost conditions in Whitehorse. So having a good understanding of how you're landscaping and how you're dealing with those retaining walls if you have a walk down type access for a basement. I saw a few drawings and weren't really thought out very well. So as we develop some example drawings, I'm hoping to also include a bit of a walkout basement scenario and dealing with frost protection and retaining walls there. The foundation plan, again, to a proper scale, footing details and all your point loads. So looking at what I tend to do as a designer is take your design layout drawings, your truss, and if you have an engineered floor system, taking those and starting to superimpose all that information onto the foundation plan so we know where the point loads are. So whether it's a foundation, a permanent wood foundation, or concrete or ICF, or you're moving into interior, you have some large point loads going down. We're going to touch on one example today of that. It's really important. Your foundation drainage details, confirm your footing. So again, making sure that you're cognizant of where your grades are and where your frost protection are, especially if you're starting to look at introducing a suite scenario and access down. It could create some issues there. HVAC, it's always important to remember where your HVAC is going, especially as you're designing smaller homes and smaller lots and narrow homes. Sometimes that's forgotten about is where a proper mechanical room. So again, engaging your trades is really important that time, especially if you're dealing with a furnace and need to get ductwork and things like that. It's a good time to start thinking about that process. Your radon mitigation plan should be developed. And again, it's not as elaborate as you see here in BC, but that should be done. And again, transposing those finished and existing grades over because that may start looking at how we deal with professional involvement, cross sections. Again, thinking floor plan, foundation, and now thinking cross section, trying to translate all that information together. And as a designer, you sometimes flip back and forth to make sure you have all that information. It helps you ensuring that you set your grade lines. That's really important, using that slot grading information that you have and properly putting it in, because especially when I show you some information on ICF, it becomes pretty relevant on what you're using for the thickness on there and rebar requirements as well. Just a few slides on the professional. So I mentioned the bulletins, the brand new bulletins have gone out to try to explain some of the changes. And these aren't actually new, like the truss design. That's been in code for a long time, getting sealed trusses, and the city's requiring that for the time of inspection. There are some challenges as well as point-loaded beams and those type of things. So permanent wood foundations. This is a condition here at the bottom, your soil condition issue in these newer subdivision, where backfill or existing earth materials are very susceptible to moisture and to frost and lensing. And I have a few examples of that. So it becomes very challenging in cast in place concrete or your ICF. Again, there's some obviously challenges there, and there's some prescriptive Part 9 code requirements. But we're starting to see some problems with, some of the newer designs and some of the newer subdivisions, and again, the soil conditions as well. So I just wanted to take an older bulletin that Richard had produced a little while ago, and just again, I probably won't read these verbatim, but application for permits where excavation is required as part of the proposed works, we need to include the site. So we went over all the drawing information. Sections noted above are required to both go across and lengthwise of the property and the property line. So again, establishing, when we're having deeper excavations, and again, when we have tight lots and deeper excavations for frost protection, or if you want to get a suite or finished basement in there, or it's going to create these really steep side banks. That's, we're basically saying you're going to need engineer and developing the cross section again, thinking past the property lines, so you're not having a negative. Whether you're building new and kind of butting one new construction into a house that's there, and all of a sudden you're eroding into their property, and that creates a problem for everybody. Or if you're truly in an infill situation, an older part of town, is thinking that, yeah, if you're having a steep cut and it's deep, then you're getting an engineer involved for slope stability and work safe items. So I just put some information in here that's coming out of the bulletin. Climatic data overview. So we touched on this. Whitehorse is unique that, as you know, experiences very extreme cold temperatures in winter, but not a lot of precipitation. So I highlighted, a few different towns, Fort St. John and Kelowna, and precipitation-wise, Whitehorse is even a little bit less. But again, it may lead to why the frost depth gets big, because your snow levels aren't developed as great, and then you have unique soil conditions as well. So typically your frost protection is quite deep, and it's interesting when you do a little research how that's actually developed. There's some contour lines that run through Canada that the government, the weather agency has developed, where you have these freezing temperatures, and they can, through an index, develop how frost depth is. The curious thing is I was doing some research last night. So again, the snow loading, we're going to touch on that probably as we do some design calculations for decks and things like that. So it's so the moisture index and the snow load and the design temperatures are the three really important things to remember. But when you were looking at frost and we're looking at climate change, when I was there, I heard for some people that it seems to be snowing a little bit more, or the snow is a little bit wetter. You've had some really weird weather conditions. When I was there, it was like went from minus 18 to plus 5 in a matter of 3 days. So, and again, who knows what the actual cause is, but um, it's just a matter of it seems to be happening, and it's interesting here. I was just kind of googling some stuff to figure out where the frost levels that you guys have there right now is coming, and it looks like when we look at freezing degree days that it's actually going to adjust. They're already tracking it the last decade, and they're projecting now that there's going to be quite a significant change in here. So this is a link off to the side to freezing degree days. So I just thought it was an interesting point to, and the code and the national code people are thinking about all this. I heard as you move north of Whitehorse, the permafrost, and that's becoming a real problem too, as it's starting to melt and creating those issues. So it may change the way we're building up in the north. It's obviously going to create drier conditions and lead into concerns about fire protection and wildfire interface. So there's a lot of things going on right now across Canada, but I think more so in the north in some aspects. I just put these in. We won't go through them all, and I highlighted a few defined terms that when we get into excavation and foundations and drainage. Be mindful what dead loads are. So as you go back and look at these, again, I'll be forwarding this presentation on. Frost action, again, just understanding how frost has such a negative um, I impact to what you're doing here on your foundations. And I think in the most part, you can't really meet the letter of the law of the code. But I think everybody's developed a process where at least you're trying to acknowledge it and deal with it. And we'll touch on that. Grades, understanding where grades are. So not only for building height when you're getting to your zoning information, but also when you're dealing with your finish. They flip-flop ground and grades, but it's really important to know what that is. Live loads. So we had talked about dead loads. So live loads is your persons and your furniture and your snow and your rain loads. Load bearing. So just understanding what a load bearing wall and what a non-load bearing wall, that comes into play a lot with ICF. Shallow foundation. So here, this is in our area. You're not dealing with piled or deep foundations, other than maybe in some large commercial buildings. We're dealing with shallow foundations when we're dealing with residential construction. And there's a few items and this really relates to professional involvement. And when they start talking about subsurface investigations, it's always important to understand what's going on. So if you're in a new subdivision, you're probably going to have a lot grading plan that you're working off of. You hopefully will have a geotech report for the subdivision or even predict for the lot. But again, as we get into more infill, we get into more sensitive soils in newer subdivisions, geotechnical and having a full investigation of what's going on, and having a number of test holes probably in the property is helpful as well, because you never know exactly what's happening on a piece of property. And we're looking at unsafe conditions. You're kind of looking at if we're talking about a safe excavation. I was partially buried in an excavation as a laborer, doing some drain tile work, and I'm very sensitive to that. So it you got to be mindful of not only making your neighbors upset as their yards are sloughing away because you haven't taken good precautions on your excavation, but just creating that safety issue. And I'm sure WorkSafe will be being a lot more diligent. We had a good presentation by them at the last workshop. So jumping into the parts of the code that we were going to outline today, I'm going to go over some general information on concrete. So if anything, if you haven't had a chance to really dig deep into this quote unquote newer code of 2020, 2025 is coming out at the end of this year and will be implemented in 2026. So there'll probably be some really good national code sessions on those. But I just want to talk about, if you haven't had a chance to look in this area, some concrete, compressive strength, and some cold weather crimes. But I think it's more of just working with what you have. So this is interesting. I'm not sure if you were aware that there's actually a concrete standard. It's a very big document. It's over 600 pages deep. It goes through the whole gambit of formwork and concrete and the principles of concrete and pouring concrete and curing and all those items. But there is a R class designation, and your ready mix companies, I'm assuming are relating their the way they're producing to this document. This is the standard. This is fairly new. Yeah, I believe it was brought in when the 2020 came in, if not the code version right before it. But it's something you may not have been aware of. And there are classes, again, concentrating for cast in place concrete precast in the field, as well as concrete used in construction for a residential building. So if you wonder where that, and it talks about, we call like your concrete setup, you got your strength of the concrete, but then how quote unquote how thick it is and how much it would slump, and you can do testing, but there's different ways of doing that now. So I just want to provide for information if you haven't, because there is a proper standard for it. I brought this item up. We're getting to concrete in the general conditions. So we talked at the workshop. I just remind everybody that when you're designing, a simple building, a Part 9 building, house, a duplex, a triplex, even a small commercial building, when you're looking at concrete, unreinforced and non-reinforced site batch concrete. So this is site batch, but any type of concrete you can have a ready mix. The Part 9 of the NBC does not have the necessary controls to ensure adequate performance of reinforced concrete. Reinforced concrete is therefore regulated under Part 4, which provide proper design and construction practice. So I had mentioned that there is no requirement for rebar in Part 9, but we all know that it's probably a good common sense idea to put it in because of, you got a little bit of cross action, you may have a little bit of different differential and some settlement set up. You got structural loading going on. So most persons that have worked with an engineer, even if they go into a more simple project, not requiring an engineer. So I just need a drink. You don't need rebar. And if you're designing, or if you're a designer and you're not an engineer, you're probably just taking some traditional common sense notes from previous drawings and transfer, but it doesn't mean you're designing it correctly. So you just want to be careful on that. If you, and then on Ontario, as a designer, you're not even allowed to put even any rebar notes unless it's in the code. And we'll go over that the next slide. So really reinforcing is an area. The only one where it's not is the prescriptive requirements that we'll go over later today in ICF, insulated concrete formwork, or flat insulating concrete form walls. So you can prescriptively have ICF buildings not exceeding 2 stories in building height and not having floor heights greater than 3 meters. So you could have a foundation coming out and wood frame on top, or if you come fully out of the ground, and you build it in stages, and then hang your walls off. These are the limitations here. There is, I'd mentioned that standard again with the concrete. There is a specific standard for that and maximum aggregate, because you can well understand that, especially in a 6-inch, you can go down to 6-inch or 150 millimeter cores for ICF, that it'll actually bring the concrete. You need to get the concrete down to the bottom, so there's reduced aggregate size there. And they go over, again, this is the only sections that we're dealing with reinforcing at lap splices. And then we'll talk a little bit more about the actual horizontal and vertical reinforcing. So again, just being mindful that you're not, if I guess if you want to, that's fine, but the city is not looking at reinforcing where it's not required. Compressive strength. This is very minimal standards. You're probably going like, who would build this? But again, you're looking more of a small batch, site batch, and really you're trying to, again, control moisture content as well for setup. But really, typically, ready mix concrete coming to site is at a much higher degree, and you probably got some admixtures in there as well. And speaking about admixtures, some standards in here. So the code outlines these standards. And it also outlines cold weather requirements. And let's go back to this. We're going to read that section on admixtures. There are article references to standards which describe the acceptable properties for admixtures and the number of applications. The quality and suitability of chemicals added to concrete need to be controlled because the improper use of chemical admixtures can reduce the strength and durability of concrete. So again, that standard that I was speaking about, that very large concrete standard, they outline these items here. And, again, you're dealing with these extreme measures in Whitehorse with temperatures. So that's pretty standard now to have that. But also when you talk about cold weather requirements, and again, it's hard talking to a group that is living in very extreme. I grew up in Northern Ontario. I know what that's all about, and how do you deal with that? And you can heat and hoard, and that drives the expenses crazy. But I think if you're getting your footings in the ground and protecting those in those shoulder seasons outside of winter. Yeah, in summer, you get those in, and really the rationale why you're seeing, you see so much permanent wood foundations up there, and you can build those on wood plates, but it seems like the standard is a concrete base. But it's really critical in those first few days to get that set up right, because you really lose that strength, and it may never come back, even if you do get some heat in there. So just being careful in those items. Structural requirements, so part 9.4, we touched on those at the workshop. We touched on those a little bit at the last session last week. So just looking at bearing capacities for soils, high water tables, and some other aspects when you're designing your footing situations. So 9.4.4, we're looking at foundation conditions and classifications of sound. So a rule of thumb for code, this is, again, mostly you're going to find geotechnical engineering. I think that's probably the best way to go, because when we talk about liability claims here in BC, the highest claims or the most expensive claims, the hardest things to fix are what's in the ground. So you want to do it right from the get-go, and make sure that you're not having any significant issues that you need to go back and try to repair. Understanding what you're dealing with in the city regarding soil conditions. And again, typically in the new subdivisions, it's reviewed by the geotechnical engineer, and then now need to do a site investigation. But if you're out maybe doing a reno and you do some test pits, there's the old school way of testing with the picket test, or if you're running into some silty clays, that you can kind of get a general idea of that. Soil conditions, because Whitehorse has a very wide variety of soil conditions you see from this map, which impact the soil bearing, backfilling, and drainage, which it's, again, the backfill and drainage is what's creating some of the issues in our new subdivisions. It's key to verify the soil conditions. And as mentioned, like particularly in Whistle Bend, the soil conditions are more prevalent to freezing and poor drainage, which requires involvement of geotechnical engineers. What I heard that some new houses even were experiencing some frost action and actually moving the foundation walls around before even finishing the building. So really important to take good care of that. And again, why we have geotechnical engineers involved. This is a document, it's not a long read, but I would recommend having a look at this. It relates to the map, it relates to what's happening here. And it's curious when you read this and you look at the pictures, and when I had a chance to be up there in the daylight. And it's very similar to what I experienced here in the Okanagan with the different types of soils and the terrains, especially along, looking down in the downtown core, and you're looking up and you're looking at all the steps. And into the mountains. It's very similar condition-wise. And again, this is a really good information to have a look at, to just give yourself a little knowledge if you're not particularly into soils aspect, is just to have a look at this and have a better general idea, especially if you're kind of wondering, why is the city taking such a hard stand on some of these items. When I look at some of the pictures of that document, you're looking at some sands, you're looking at some silty, sandy situations. You maybe moving in some clays. You got a lot of riverbed situations, a lot of granulars, and just trying to judge some of the bearing capacities. So I took a little bit of a guess where we may be in here. Again, you get some really good bearing capacities with your compacted sands and gravels, but as soon as you dig into them, the angle of repose, once you start digging them, and you got to think about when you're doing your infills that, if you got stiffer silty clays, or silty sand, that they're probably going to stay somewhat intact on a more vertical, and you think everything's okay. But again, that's a work safe situation. But you may be in a more of a gravel situation where you start digging and all of a sudden it's just eroding away. So you got to be very mindful of how you're going to attack that excavation in these situations. When you're looking at items regarding stratification of soils, it's important again get those tests in because the code is where rock and soil within a distance equal to twice the footing width, and you can see the picture on the right. So there's width of the footing and then double the width. You got to be mindful of where your soil conditions are at because you're basically when you read these code sections, you're taking kind of the worst case scenario to design at. So again, you may have some stratification where you have good and not so good. So you got to kind of think about the not so good in these situations when you get into these 2 to 1 width depths. Same with high water tables. So when you're in the kind of the older downtown core area, I was talking to Richard and a few other the officials that once you dig in, again, much similar to what we're experiencing here in the lower part of Summerland where I live, or again in Penticton. As soon as they dig 3, 4, 5 feet for sure, you're hitting standing water from the lake and water courses. So being really mindful that you're reducing your bearing capacities when you run these situations. Again, more prevalent to have engineers involved there. Soil movement, this is, quite a significant thing that the building officials will tell me, and again, why they've been taking a harder line at this and why already you're experiencing some failures with foundation systems and not as they're not being really thought out on the backfill. And this is a picture that was sent to me. This was last year, and you look really close, and again, I'll send this on. There's these really fine lines running through here, and this is ice lensing. And even though these are very tiny lines, say like it's 1 millimeters thick, if you get enough of them, imagine you get 25 times 1 millimeter, that's an inch. That's an inch of movement pressure. And you can just imagine that pressure on your sidewalls lifting up. So again, got to take particular attention to this and why maybe now, again, newer subdivision, different soil conditions versus what you were dealing with in the older parts of town, which more had that those pictures where you had more of that gravel, that not cobblestone, but we got a lot of that here in Penticton. But really that old riverbed scenario where again it can really free drain. You don't have those type of materials, the pyrites and those type of things that are an issue and can create those hot pressures later on the foundations. Excavations. So we've been talking a lot about site safety and infill. I think it's just trying to drum that in. I'm an older guy. I'm a visual guy. And I repeat myself a lot just to try to make sure that I'm understanding it. And then, as a group, as a team, we're a building industry team from building officials, everybody involved on the other side of the counter. So I have an example house, and you start thinking like, I'm going to dig. I want a full basement for one. Probably, got to excavate anyway for frost protection, and you might as well use that space because of the economics of building now. But you really have to be careful. And again, WorkSafe has some very strict standards, and that's why the city has, those standards as well, and trying to challenge builders and designers to think appropriately logistically on your site grading plans. But even in a concrete standard, even think about stockpiles and vehicles, delivery vehicles. Concrete trucks is just protecting the excavation. Those are those little pictures at the bottom there. Cave-in protection, slope walls. So again, creating those safe slope walls, and it's very difficult. And that's really, getting your professional involved and trying to determine what's going on. Do you have to protect those banks? Do you have to do something else to make it happen, or do you have to bring the building up out of the ground so you're not going as deep? And again, that creates other problems. Part 8, if you weren't aware, there is a part 8 of the National Code, and it deals with site safety measures in construction and demolition. So if you're removing a building or a portion of the building, or you're building new, there's very specific site safety standards, and ensuring that emergency responders can adequately get to the site. But you see in the top, this is a picture that Richard sent me about an infill development, and it's a stiff material in the soil, but what happens if you get rain? What happens if you get some vibration and you get, there's a surcharge that's going to quickly erode, and down goes that fence, and there goes all your problems to try to deal with that, right? So you want to protect your property, and that's part of the code. And again, you also want to protect if you have buildings on the property or next to a property or retaining walls that, on that picture on the right, there's that angle of repose. There's that pressure point where the footing pressure from above, on an existing build that's a little bit higher, it's pushing down. So you got to be very mindful when you're doing retaining, you're doing your landscaping, you're constructing new, because you have really tight lots now, very small setbacks. So you don't have a lot of wiggle room, especially if in an older building that's maybe not set at a deeper level that your home is. So put your attention there. Excavations, again, we talk a lot about freezing, but I think it's just a matter of, taking reasonable precautions, making sure that, if there is soil movement, that you're all moving at the same time. The soil conditions, and as you're building out, and again, heating and hoarding is probably one way of keeping it firm, and not building in the winter at all, but that is not practical. So I think your the building community has lived through it and found a way. But again, just trying to put some reminders in there, and looking at frost protection, just showing you where these come, and you don't really fit the standard tables within the code. So on the right, you have your foundation conditions that relate back to your type of soils on the left of the screen. So you got on the right, it's talking about, dense, compact rock, all those kind of things. And as you move over to the left side of the table where you're looking at your minimum depths of foundations, but really you have a deep foundation situation, or else you get an engineer and you can work out some items related to trapping the heat in with insulations. And I saw some really great drawings and details on that too. I'd also say that since the drainage layer, you don't have perimeter drainage per se. There really isn't anywhere where that water can be taken to a sump or to a city storm. I think just based on, particularly if you got deeper granular layers, that you're probably taking the lower. I'd probably stay to the lower of the bearing capacities when you're thinking about designing strip footings and pad footings without an engineer. 75 kPa or 1,500 pounds per square. That's just maybe my recommendation that we can talk about as we go along. This is an interesting, and I brought this up at the workshop, that part of the concern and the development of the codes over the decades is, we're going to understand we're going to let some of the heat out, especially if we have footings at or above frost lines. And again, since your frost line is so deep, it's almost better to let a little bit of heat out, and keep that space conditioned so you don't have these adverse effects from frost. But then you have the energy efficiency requirements where you're getting more and more insulation in and around and under these foundation systems and slabs. So we're trying to work with both ends. And again, this is I was working with Richard, and I want to finish these details off. This is one of the CAD drawings that I've been working on, and looking at some of the different design details. Some of them had the insulation down below. So the building bylaw requires this energy performance requirement, and having this rigid. So I'd like to go over this a lot more as we move forward in the next sessions of trying to develop these details and get them on the drawings, but also getting some isometrics so we can develop the guide as well. So I'm really looking for your help here as a design and builder in the industries here, and just trying to bounce ideas off and trying to negate some of the issues that we're seeing right now. And we're going to look at, more of a shallow situation. We've got a shallow crawl space, so you're probably going to get an engineer involved because those dynamics. You can have your permanent wood foundations go quite deep and then backfill, and then kind of have your situation that way. But that probably is not cost effective to do a trench and then put your PDF in and then try to go around it. I've seeing concerns where we have this footing, we have say on the picture on the right here, you have a deeper excavation, you got your granular layer, and again, the granular layer is helping you as well because the water isn't, the hydrostatic pressure or whatever may be down there is not creating some adverse issues regarding frost. But you also have your insulation or perimeter insulation. You have a little bit of heat coming out of the building as well, even though we're insulating those situations. But here you may start seeing people not dropping their footings down for their decks and roofs. And that can be really problematic. Even if they are in a granular layer, even if you do bring the insulation over, you're probably going to see some action there because they're away from the heated building envelope, and they're going to see a little more action. And this is one example. Richard's been watching this one for a while, or his team's been watching this. So Richard sent me this when we were in discussions of doing the workshop. So in November, when you're getting your initial cold and snow, so that's the top picture, and then on the bottom you can see it's even more aggravated. It may not look like, but it is the same building. You can see it's really significant. And when you look at the blown up picture on the right, you can actually see that it's actually pulling away. There's actually a very obvious. So this is the house is set. It's protected. It's not getting that frost action, and then you're getting your front deck, your roof, and then you probably have a deck at the back as well. And there's three significant issues that could happen there. You've got your deck sloping towards your house, and this goes with grade as well as you get your frost in the ground, and then you get into shoulder season, and it all starts going all over the place. You get your deck sloping back, so then it's feeding moisture back in. It's also becoming a hazard because then your decks are lifting at the front end, the most extreme end, and it's pulling away from your stairs. So then your riser heights are no longer set properly, and that could become a tripping hazard. And over several years, and you can see just on the right, that blow up picture, that it's actually can be a concern with the building envelope failure because it's cycling, it's going up and down, and you take a pen and you or any kind of silverware and you start bending it up and down. Eventually, it fatigues and breaks. So one, it could fail structurally, but probably more so sooner it's going to fail a building envelope, and you're going to start getting water in there, and that's going to create a lot of problems fixing that later on for the owners. Backfill, we're going to repeat this message quite a few times. Two principal causes of a basement wall leaks are inadequate grading around the foundation and poor footing drainage, and proper grading away may cause drain water from the roof, driveway, or surrounding areas to flow towards the foundation. So being very, very mindful of what's going on there. So you have your backfill, you probably, you may have some compaction in there, and then you eventually have some settlement. The ground around the building should have sufficient initial slope away from the building so that future settlement will not cause drainage towards foundation. On average, the backfill could settle to the 4 inches, depending what type of materials. You probably, again, want to do a little bit there. And you want to create positive slope out, 1.5, 2 meters. You probably only have 1.5 to work with. And you also want to think about, and I think some of the city documents come up, and you'll look at the preserved wood foundation details as well, that to put a little bit of capping material that, again, to drive the material, the rain precipitation away, and hopefully you got enough on there. And you got to kind of play. It's like, now I have a sidewalk, and it's like, how much slope do I want? Because that could become a safety concern, especially in inclement weather conditions. Just a note from one of the local engineers, just reinforcing a point about backfill. That's why I highlighted this. So, we've been going over backfill must be placed to avoid damaged foundation walls. Again, materials going there. You don't want frozen materials in there and damaging the walls. You don't want large boulders going and rolling in there and damaging the walls. Grading should be sufficient to accommodate the settlement. So that's 912.3.2. And then the highlighted area, the backfill, again, be really cognizant of what's going back in there. If you're in a subdivision that has poor soils, you're unfortunately thinking about bringing in materials to try to deal with that. And just I'm going to read this from Adam. Part 9 backfill requirements require that non-frost susceptible soil be used for a backfill around the foundation unless other materials are suitable at the recommendation of a geotechnical engineer. Therefore, to backfill around preserved wood or permanent wood foundations with typical, like our new subdivision of Whistlebend soil, meet the requirements of Part 9. Every house will require additional geotechnical engineering and field review. The only way to get away from needing an engineer for backfill would be switch to something like more robust, something concrete. But again, concrete has its logistical problems, and that's probably why you don't see a lot of it other than in some commercial. But the insulated concrete formwork, ICF, and we're going to touch on that in today's session. So it's important, or frost or import frost susceptible, non-frost susceptible backfill requiring all materials excavated to be hauled away and disposed of. So again, becomes a bit of a logistical return on investment challenge for you. If you're used to building one way, I know it must be tough to try to think like, oh shit, now I gotta. Oh, sorry, I shouldn't swear on online, but um, but yeah, it's really tough to kind of change things because change is hard because there's so many people in play. And that's why it's really important to integrate a design phase to really start thinking, well, hey, this is what we're facing as a design team, as a building team with your trades. How are we going to make this change? And this may one, it's like maybe the way we've been doing foundations is not really going to work anymore. So are there other ways? And I just want to touch on that today. And just finishing up with trenching. So you know this already. If you start mucking around and digging around your footings, you got to try to make sure you're protecting those areas to avoid settlement. And it obviously becomes a big problem when you have non-reinforced concrete, but you do have some rebar probably as a common sense measure. And so it's probably not seeing the ill effects of that so much, but there are some precautions to take for trenching. I'm going to take a little bit of break. Let's take a 5-minute break. We're going to be Yeah, let's come back at 9, actually. Let's grab a coffee, bathroom break, and then we'll jump back into a session. Let's make it at 9 o'clock. I'll start rolling again. Okay, thanks. And if you have any questions, put it in the chat or email me at ken.flywheel@gmail.com. Okay? All right. Hopefully everybody's back. And I think I did time change mistake. I said 9, it's actually 10. So apologize for that. So I'm gonna jump back in here and hopefully you're still there. The next section that we'll touch on, and again, all these are, I'm not doing deep dives. I'm just trying to highlight these different parts of the code and where I feel, um, it may be of interest or concern, then I'll highlight a very specific code item, especially in this section. There's so much to go through, and I just want to make sure that we're touching on a few of these items and that are developed in the drawings, the example drawings, and the cross sections and those type of things as we move forward over the next few weeks and months in development of the guide. So we'll just touch on a few items: scope of the application, required dam proofing, the preparation of services, and again, more so when we're dealing with ICF. I got some specifications from our 406 permanent wood foundation, protection of soil gas. So a little bit of, we're going to talk a little bit of radon. And even though it's not as developed, we're seeing in BC, it'd probably be moving that way in the next few code cycles. So I just wanted to touch on a few processes there. So scope and application. This section presents measures to control ingress water, moisture, and gas. The subsection 13.2 applies to below grade walls. So that's really where we are in this session. And floors on ground where drainage provided in accordance with section 914, which we'll touch on as well, an entire below ground portion of the foundation wall. Subsection 913.3 applies to below ground walls, floors. So, and that's more into play with just 913.3 is more when we're starting to deal with waterproofing. And, I'm not really going to touch on that, even though it can be problematic in your lower areas of town, closer to the rivers, that you may have to consider some of that. But I'm just going to touch on the damp proofing and soil gas for today. Dam proofing, required dam proofing, once you put a building in the ground, you got to be cautious of what's happening on your walls and underneath and trying to create that moisture. This line item is actually talking about when you start looking at different elevation changes within a building, and you may not see a lot of that just because the challenge they have with frost action and that. But you may see some conditions where a crawl space drops down to a foundation, and then you got certain details for your permanent wood foundations, and then if we're looking at other types of foundation setups, just being cognizant of that. I did want to bring out the one item of preparation of services, because you're going to see this a lot in the code cycles moving forward, where they talk a lot about manufacture. So in sentence 3, where the dam proofing material is to be applied on insulated concrete formwork, the walls, the instructions of the ICF wall manufacturer shall be followed. And you're going to find that a lot in the code, where it's going to say refer to manufacturer specifications. And, again, now you have to find the manufacturer specifications and make sure your team is working under that. And then the building official also has to do that. And this is interesting. If you're not aware of this organization, the National Research Council, they have a testing agency. And a lot of the Canadian products are required to be tested to meet certain standards, whether they're CSA, ASTM. And this in particular one, this company here has gone through the gambit of developing their own water, membrane, dam-proofing membrane. It's also a waterproofing membrane, and it has to be installed in a certain way. And there's some conditions as well. So just as an example of one of the industry changes and in industry product proprietary, the companies are actually developing these and wanting to use that. Not saying you can't do something else. You can still use traditional dam proofing, which is difficult on ICF, but then you have to protect it from damage. The membrane itself here is robust. That if you got a small little boulder or something like that, or somebody bangs against it, that you're probably going to see that damage. Or you use that Delta, the dimple board stuff, that also helps, but you usually use those in combination. In the 406 standard for dam proofing, they go over some particular items in here. Some materials installed provide required damage shall possess the characteristics necessary to provide protection from moisture transfer from the ground. So again, very similar to what it's outlined in the code. Again, very similar wording regarded to the materials that you're using. poly or using some kind of cold fluid applied hot rubberized bitumen, those materials to really seal up those areas there. And then it relates down into the bottom sentence here, moisture and vapor barriers, and it's saying those must meet Part 9 of the National Building Code. This brought up that another section regarding exterior moisture barriers and some detailing here. So just thinking about how that's going in, how it's being backfilled, how it's being protected at the top. And when you think about that transition at top, you want to make sure that's a really good, that little detail A on that picture. You want to really make sure it's firm. And when you're thinking about ICF, and you're looking at those details where you're getting backfill and then finish grading after that, a lot of junk can get down there and cause some problems. So you want to be cognizant of sealing the top of those, any type of those membranes that are up against a foundation wall. And I'll go into detail, but I just wanted to show you this actually in here. And if you haven't had a chance to look at that guide for a while, it has been updated. And I'd highly recommend that you get a copy of that. Damp-proofing floors and ground. Just your standard. You're probably already just using 6 mil poly, but it's just outlining this. It's outlining, the laps jointing. It doesn't necessarily need to seal them, but that's also a good idea too. Using the right type of tape for poly, which is usually the blue, not the red. But you're just overlapping these, and then typically your concrete slab would go on top of those. There's also some allowances regarding rigid, extruded, expanded polystyrene with sealed and shiplap joints. Again, allowing for some of that in, but I'm not sure how prevalent that is in Whitehorse. Now we're going to jump into some flow gas, and we're starting to look at radon concerns. It's a little bit light. I did check with one of the organizations just to confirm that I had my head in the right space versus where we are. We've gone pretty far, pretty far on the piping and so forth, and I'll touch on that. But here it's like in sentence 2, unless the space between air barrier system and the ground is designed to be accessible for future installation of subfloor depressurization system. Dwelling units and buildings containing residential occupancy shall be provided with rough-in. So that's just a rough-in for radon extraction. And I just put in brackets there. We're kind of looking at unfinished crawl space. We can get in there after the fact and kind of really finish things off. That's a bit of an exception, but they're really saying that if you're in a residential situation, that you want to be able to have that set up for future. Because again, when you look at Whitehorse, it is in the radon zone, and some really great mapping information here. And the YG site has some really good information as well. So it's there. And again, as we seal buildings up tighter, we really need to be a lot more cognizant of radon detailing. This is from a Canadian guide. So the two pictures, again, I know it's showing, concrete foundation walls, but I just wanted to show it because even if you're using permanent wood foundations and those are sitting on a concrete foundation, you can really start getting some good detailing going on because really the pressure of the concrete sitting on the top of your footing and creating those sealants at those points and then sealing it again around the building. I just want to put a warner. I'm just providing this as information, so as a reference point. But I have talked to a few people that go in after the fact and fix basement systems, why they're not working, especially if they put in an active system with fan and they're not working. What they seal out in the sealant on that picture there. If you can imagine that your concrete is moist, and as it cures, the moisture leaves and it shrinks. So you have the sealant, and sometimes people go in right away and they'll seal it, and then the slab will shrink, and then all the caulking will fall apart, and it's not doing anything. It's probably best to let it sit. And I know this is just a logistical problem and just more labor, but you may want to actually rod and caulk that area. The bottom picture, again, it's talking about allowing, if you have different footing, if you have a footing, say down the center of your building, and you need to get the radon control. I know it's probably a little bit different because you do already have the drainage layer, and now you're adding a little bit more in between. But just being cognizant of getting, if you only have one port, I'm just gonna, one port like this one here. You want to make sure that all the availability of that radon gas can be moved to one spot and then later hooked up as an active passive or an active or full active ventilated system. Just some details, and even though this is just showing the wood plates, there are some details on air barriers. So again, if you haven't had a chance to look at this guide, I'd have a look at this guide and incorporate these design details in your drawings. And just going back here, you just the reference point when you're looking at the bottom here, required installation of granular material, which is referenced in 3A. So clean granular material, 19621. So that's the bottom. And then it's very similar to the wording of the drainage material that you're putting in for your drain perimeter, instead of your perimeter drain town stuff, you've got that drain layer there as well. And I had mentioned the Canadian guide. This is, you can access on site. I provide the link on here. It's free. And it just starts saying about if you want, or somebody, your client wants to move, set up full passive system where where the national code may be going to. BC was stub it at the slab, and then they found problems with that of hooking it up later because it was not in a really great spot, or people thought it was a plumbing fixture because it wasn't labeled properly. So again, this is just a guide to walk you through and some of the other details I had in there. We're going to move into drainage, and I'm going to move through these fairly quick because I do want to talk about some of the foundation conditions. So really, precipitation comes down, you want to try to control it at the roof level and move it out to the sides and away from the building. And that's really the principles of foundation. Unless it can be shown to be unnecessary, the bottom of every exterior foundation wall should be drained by drainage pipe, which is not prevalent in Whitehorse. So we're going to look at a layer of gravel or crushed rock in conformance to 9.14.4. They also state a number of times in the code about or mineral fiber insulation or crushed rock backfill. So if you're able to put some, like that was rock smartboard, the Roxol in there, that actually helps really create not only your insulation and from my understanding, the R values stay pretty constant even below grade in wet conditions with Roxol. It allows for a drainage path as well to get down to the bottom, which will eventually get down to your footing base and into the drainage layer. So they seem to repeat it a couple times in here. So maybe something again to look at your design details and if that's able within your parameters to set up. Type of grounding material, it talks again about the materials going in. You don't want it to be a point, especially again talking about your drainage area. You don't want it being able to compact because it's not then really doing its job. Same with the rock, radon rock underneath. If you're seeing materials, and I saw it here a few times in Kelowna where they're actually running a compactor over, it's like you're using the wrong material because it's not allowing that soil gas to actually move through. So they actually use the wrong material. So you'd be really cognizant of materials going in there and in the depths. So when you're looking at that drainage layer, it's a minimum of 125 millimeters in depth, 5 inches, and then at least 12 inches or 300 millimeters beyond the footing base. I did talk to Richard about a maximum depth, and I believe they were talking about 300 millimeters without, again, if you're not having an engineer involved, and you probably will in a new house development anyway, but you have to be careful that, you put all that material in and it's not really material that should be compacted, then you're losing the bearing capacity on these. So it's a bit of a trade-off when trying to do those. And then the grading, the bottom of the excavation shall be drained towards your sump. So again, you're trying to bring it in towards where your sump action go. Here's some detailing right out of the S40616 standard. So just as a reference point, so you could have the footings, and you'll look on here in the top right, you're having the footing sitting on the drainage layer and then granular drainage layer filling in underneath the slab. So it's a concrete slab with a permanent wood foundation, or you could have it set up, and this may be an item when we talk about ICF where the loads are a lot heavier, the actual dead loads, because you got full concrete foundations. You may want that footing sitting on undisturbed full bearing, and then your drainage, but then you have to find some way of moving that potential water and that moisture back into where your sump is in the building. Because again, we're not relying on a drain tile system. Surface drainage, we talked about that a few times. So in the code, basically getting the grading away from your building so that water won't accumulate near the building. And then downspouts, trigger attention at the end, what you're doing with your site drainage. And this is one detail again of just sloping it away to give it that positive slope away from the building. You may have another lot that's coming towards you too, so you're creating some drainage concerns. One of the times when you're doing these drop downs. Again, I asked which where did your storm go? Why isn't it going into the ground into a piping system? Is what has nowhere to go. So again, you want to bring that back and just dropping down. You want to extend that pipe, the rainwater leader and the extension away from the building because you want to move that water away as far as you can. It can be problematic because what happens after post occupancy? They may get sick and tired of tripping over it and hitting it with the lawnmower and take it out. So you may want to think about how you kind of set it up to not have the owners kind of manipulate that later on. But here it relates to roof drains in sentence one to part seven, which we're not really covering in any of these sessions. That's the plumbing code. And again, thinking about getting that water away in sentence two. The city has developed some guides. This is a fairly old one, but I think it holds the test of time. So I've just provided this as a reference point. Just to remind everybody that the city isn't just making all this new stuff up. It's actually has been. It's maybe just kind of been lost in the weeds for a while with all the busyness and all the changes in our industry over the years. That this is an area and a document that you might want to look at regarding drainage standards for building foundations. And in the drainage, they have a really good newer drainage guide. And just thinking about moving water away from the building, collecting into a swale. And those swales are moving front and back away from the property. So they talk about roof drainage and they talk about swales within the guide itself. Moving to footings and foundations, and I'll have to move through this fairly quick, unfortunately. Some information on footings, flat insulating concrete. So in a general case, except as provided in Articles 915.1.2 and 1915.1.3, this section applies to concrete or unit masonry foundation walls and concrete footings on stable soils allowing a bale. So you look at this 75 kPa. So if it's below that, then you definitely need a soils engineer. Again, this is the minimum bearing capacity. And when we go back to those charts that we were looking at, just being cognizant of the soil conditions you're working at and what your geotech reports that you have in front of you and you're designing. And then you're looking at for buildings of wood frame or masonry construction. So again, these footing stipulations here. It goes on to wood frame foundation walls, but it also relates to the 75 kPa, or greater, which I highlighted here. And again, for buildings of wood frame construction, flat insulating concrete or ICF in sentence C on stable soils with allowable bearing pressure of 75 kPa. So again, that minimum standards. And for buildings of light frame, so it could be light frame on top or flat insulating concrete for construction that not more than 2 stories in height. So again, there's some limitations because they do realize the weight factors involved and any other design principles as you get a higher and higher building. Foundation application other than described, again, fall into 9.4, we're requiring an engineer. Just looking at your load, so you're looking at your gravity load, so those are the pink arrows coming down. Foundations carry their own weight. And the loads transferred to them from the superstructure they support to the ground. Vertical loads include the weight of the superstructure itself and that of the occupants and contents. So we talked in the definitions, there's the dead load. So that's the weight of the superstructure and the live loads. So persons and snow loads and those type of things. Wind and earthquake can also factor in those. And we won't really touch on those. I will in the next section, session 3, we'll talk a little bit about those lateral load conditions where foundation extend into the ground and they close, which again, we're dealing with foundations. There's a lot going in, coming down. There's a lot of pressure, hydrostatic pressure, soil pressure going in, potential uplift. So thinking about all those things as you're designing. Footing shall rest in undisturbed soil. That's probably always a given, or compacted granular material. No, that's really tough, pretty for building officials in ensuring that the material say it's quote unquote structural fills going in there has to be tested properly. And that's probably more than likely where you're seeing a professional engineer involved. And when we're looking at basic principles of the code, again, unreinforced concrete footings and forms and widths, there are limitations of how big these buildings are. So if you have a house and you don't have an interior bearing wall and somehow you're spanning maybe a deep TGI or a parallel cord, if you're exceeding those spans of 4.9 meters or 16 feet, you're getting an engineer involved. Or we're getting higher water table conditions, you're getting an engineer involved in your footing design. Here's an alternative. We brought this up at the workshop, and one of the persons in the workshop stated they had tried this, I think, for a deck, but unfortunately, the density of the soils or the bearing capacity of the soils was quite loose, and they actually had to drill a lot deeper than they thought. But this is perhaps a potential alternative, especially when you're dealing with smaller buildings, maybe even manufactured housing, that you use this setup and maybe an easier setup. And there are some standards, and Alberta is kind of taking the lead on it. But I do believe that the national code and here in BC, we're starting to look at this a lot more. Just to go into footing designs, and I've highlighted here. So this is the chart in for minimum footings, the prescriptive measures. So we look at a foundation, we have two, and then 2 stories. We're looking at this table here. So supporting exterior walls, and this is the minimum width of strip footings. For 2 stories, it's 350 millimeters, which is 14 inches, I believe. And then same for supporting interior walls. So that's your standard on there. And then you get into the minimum footings for columns. So whether it's an interior or an exterior deck, you can look at this as they standardize these spacings at 3 meters in a 3 or 10 feet. And I'll show you why, because I did a little bit of quick calculation on the house design, and we're kind of looking at you could have a single story deck, or you could have kind of maybe an opening in a room in the basement, and you have loads coming down. So if it's not at 10 feet or 3 meters, you can actually use a ratio, and it's usually the longer width over the 10 feet, or in this case, it could be 3 point something over 3 meters, and then you use your 0.75 is your standard pad footing width. So you can using the table at the 0.75, then the spacing ratio adjustment. So it's the longer over the standard length. And it gives you that range. So now your footing has to be increased on it. So you can see that you have to be really cognizant of it. When you look at the footing thickness, though, so we established, whether it's strip footing at 12 inches or 18 or 24, depending again on your on what's coming down on it. But now you got to think about your footing, because you have quote unquote unreinforced footing, and you see the picture on the right. You have these loads, whether it's a wood foundation or an ICF or a concrete wall, it's coming down, and the pressure points from that wall are actually pushing down on the footing. And if your footing's really wide but not very deep, you could actually create some instability in the structure of that footing and actually cause it to fail, which is not super great. So there is a magic width. And when you look at the angle of repose or look at the angle of it pushing down, it's usually at 45 degrees. And I'll touch on that. There's also step footing. So if you're stepping down, you're probably fully aware of this, but just as a reminder that you can only do that so many times. And again, we're thinking about Part 9, and it's unreinforced, and unless you have an engineer involved. You're usually sticking to those parameters of 2 feet and 2 feet horizontal and vertical as you're stepping down into the site. Here's a little drawing that I did, and I started working on some calculations. And I'm sorry, I'm going to do a little better copy when I update this. But when you look at the strip footings, so we looked at strip footings in the guide and table before. So exterior strip footings and interior. This little house diagram is at 14 inches at 350 millimeters. There's no other, we know brick veneer and anything that could be another factor in it. When we look at the footing for the pads, in most cases, it's fairly simple on the exterior. I highlighted the red. I'm going to follow up in the next session when we start looking at the framing. But on the picture, you see the front of the house on the left. It's got a little deck out the front, single story with the roof. But the back is actually, it's 2 stories deck with a roof. So we have to be very cognizant of what's happening on the loading there and your depth, because the thing I wanted to show, and you see these little diagrams of profile of the footing, is that you have your bearing capacity, and you have to figure out, like, okay, if I have a column, a 6x6 column coming down, and it's hitting that footing, and even if there's a slab on top, and I think we can talk about that a little bit more, but you're coming down, and it's putting all that pressure, that load, and then shooting off at 45 degrees, and then your thickness of your footing, because you don't want that arrow kind of you don't want that 45 degrees creating that, what we saw on this last slide here, that concrete footing on the top. You want to make sure that that line actually is hitting the outside. And when you get into pad footings, that becomes more problematic, even though again, you're probably reinforcing that even, or maybe incorporating some of that slab. So there's different ways of doing that I'll go over a little bit more in the next session too, as we're laying out the framework. But I was just thinking about showing you that, we have loading of the floors onto the exterior walls in green, and really probably only taking about half of those loads. But um, when I get into this situation here, that's why I had these, you got taking half that truss span, so it's 24 feet. That's coming down your exterior walls to your footings. You're taking those loads of the walls, or sorry, the floors, your 2 stories, and those are transferring out to the walls as well as the interior. And then you're having the pink. And those are your concentrate loads, where you have a bearing wall from the top floor coming down to the basement level to your floor system above. And then now you have this opening that you're creating. And I showed a little bit here on the left, the shear plane. You have your natural bearing, you have a granule, and you have a footing, and you have your preserved wood foundation, and then you have that angle at 45 degrees. So in this case, you can have a fairly shallow one, but as you get bigger and you get into concrete, you have to be pretty cognizant of that. And really, that's where that pink, you're taking that tributary area and you're trying to calculate loads. And when I actually used the column spacings in the tables here, and then did actual physical calculations of 50 pounds per square foot, that your dead and live loads times the area times the levels, it actually worked out really close. So it's based on about the 1,500 bearing capacity that I was talking about before, the 75 kPa. This is a reminder, and one of the building, I think it was James, reminded me when we were looking at some of the detailing here, is that in sentence C, when you're looking at preserved wood for lateral support, and again, I mentioned there seem to be some failures going on in some newer construction, and mostly based on some freezing of the soils and this lateral push happening. For anchor bolts, a squash block of the same cross-sectional dimensions as the bottom plate shall be nailed on top of the bottom plate for the anchor bolt passing through both the bottom plate and the squash block. And a 2-inch minimum washer shall be installed. So very prescriptive. So you need to ensure that you're setting that up for success and reading these standards in here. It also, when you go in here, it actually talks about once you start drilling those, you have typical preservative treatment. So sentence A and B. You're looking at some preservative going there as you're drilling. Again, you want to protect that as well. And then you want to make sure that whatever you're using for your fasteners is applicable or safe to use with your preserved materials. And we went over this one here, and I'm going to develop that a little bit more as we go through the guide. Just being aware that I just threw this in as the inspection part, is that now you're at the stage, your first inspection, you got footing setups, you got to again make sure your drawings are in sight, your permit package in sight, you have safe conditions. If you're working in a protected zone area, you may have some water course issues, some other environmentally sensitive. All those are set up so when the building inspector goes out, he has the package. You have the parameters to work safely within. And then, you're more likely having your geotechnical come out, you have your granular material set in there. You quote unquote your cold weather condition provisions set up as well, and getting all that paperwork in place, and then continuing on, looking at we went over step footings, your pad footing sizes, making sure your site team is always referring to the permit issued drawings. It may be tough to keep it on site, and especially in weather conditions, but have a copy made, keep it on site, keep a digital copy for everybody to have on their phones, because if they're working off a different set of drawings, then things can go sideways pretty quick. Either with your engineer coming on site or your building official trying to check things off. And then it'll be a visual check on your zoning setbacks and your frost protection, your thickness. So again, you may be making adjustments. You may decide that, hey, I want a foundation, I want basement access now because of, whatever reason. Then you have to start looking and accommodating for that and talking with your building official as soon as you can. And then looking at your plumbing items. Flat concrete work. We're really running out of time, and I really apologize that I made this a bit too long. But I wanted to really emphasize you can use ICF. There are some limitations on it. You're looking at earth pressures, you're looking at maximum heights. And what I did is I'll just skip to it. There's some really prescriptive tables in the code. So again, you can do this all prescriptively, your footing design, your foundation design. So again, this may become more prevalent for you, especially as we move into new subdivisions and you're having these issues with preserved wood foundations and the complications there. But I just want to be mindful that when you're looking either at a 6 inch or 150 millimeter or it's 200 millimeter, 8 inch thick wall, which is probably the standard for ICF, there's limitations how much backfill. It really relies on your concrete. Your concrete probably being sent out is probably a lot stronger than this, but the code is a minimum here. And you can see on the top box in the red maximum height of finished ground. So you always have to be cognizant with your finish grading, your elevation points, and how you're going to use your ICF. Foundation walls are considered laterally supported at the top of the wall. And it's interesting, this is just an example of one of the code sections that leads into another code section, which leads into another, but basically saying the insulated, can consider laterally supported at the top by using tying your framing in, your wood framing system in like you normally would with an anchor bolts. And then when you go into, so that's in 920 and then in 923 anchorage of the building frames. So it just steps into these portions here of what anchor types anchor bolts you're spacing. In it, foundation will consider lateral support at the bottom. So we're thinking about top, but you're also thinking about the bottom when you're looking at ICF. And there's two ways. So one, you have very minimal backfill, so it's sitting proud. But again, you may then now start thinking about frost protection issues. So that's sentence A, is the depth of what's going on and the backfill support going on. B is you're looking at a shear key to tie that base of that wall, that ICF, that concrete, into the footing, or it's dowel. The thing is with sentence B and C, there doesn't really be an explanation of what a shear key size is. When I was building and we're looking at commercial, you'd take a 2x4 and bevel it and protect it so you could pull it out after, and set that in place to create that shear key. Or dowel. The dowel, there really isn't a length. Do you have to bend it and set it? There really isn't a depth there. So I'm hoping to do a little more investigation on that. But as long as you're meeting these minimum prescriptive requirements, should be okay without elaborating it too much. I'm going to be forwarding more of this information on as we move into the next sessions and developing the design drawings. But it may seem complicated. And it may seem like, wow, that's a lot of rebar, but you have to be really cognizant of how thick your wall is. So whether it's a 6 inch or 8 inch wall, and how much backfill. So you can see here, it's 1.6 meters. It's 6 inch core, concrete core. There are some other parameters when you're designing prescriptively, and this gets messed up all the time. When persons are on site and they're not looking at the code or not looking at the drawings, you at the top, you have to have one horizontal bar. It has to be within that 300 millimeters. And it gives some other parameters. It has to be on the inside half. So that red line is the halfway point of that concrete wall. And it has to be on the wall section on the inside. And it has a minimum cover of 30 millimeters. So again, all these parameters set up to make that happen. And then we get into the vertical reinforcing, which now you see here is 250. And it really goes from 150 core to 190, the 8 inch, or the 240 core. These are some tables prescriptively, and I'd be more than happy to go over this more in depth if there's a few people that want to learn about this more. We can set up a quick follow-up call, because I did run out of time, and I apologize about that. But it really, all this vertical reinforcing really relates to the thickness of your wall and the amount of height you have from your finish grade to where your slab is. So really thinking, if you can think about those parameters, you should be doing okay. And then reinforcement of fine form walls. Just again, a little more information in there. It's talking about if you have a cold pour, if you're pouring in stages, that you have to embed some verticals in there. So that's that sentence 3 in cold joints, and reinforcing around openings. And I'm just going to move into this. So this is kind of a finished detail. So if I were to take this house design, 24 feet and wide, and went from a preserved wood foundation to ICF, this is kind of what it could look like. On the right side, we have a 190 or 8 inch core, and the reinforcing gets a little bit different because our core is bigger. We can actually have a little higher finished ground versus what we're dealing with on a 6 inch core ICF. You're looking at your verticals. The horizontals never really change. And the other parameters about where it's embedded within the wall itself. But the spacing is, because you imagine you're getting less concrete. And again, that comes into play with the concrete material you're putting in. You have to order the right concrete with the aggregates so it can actually get down into there and not get any settlement issues. But again, you can see how it's set up. So really, when you're thinking about ICF, it's more about how deep it's getting into the ground, and that kind of relates to your vertical placement. In If you want to put an opening, and those are the two slides that I just skipped over for time, you have to have concrete above it. So again, there's a minimum bandwidth there. There's some horizontal bar parameters in it, and that's really it. As long as you're staying within, there's two. This one's set up for this one. It's within. Let's see, it's not more than 600. So sentence three, 600 millimeters and 3 meters. And that was that scenario I have now. So again, it's not a big opening. If you get into a bigger opening, you're actually starting to have a lot more robustness in the reinforcing, even, looking at sentence four, lintels. And having stirrups. So you can do it. And again, it is prescriptive without an engineer. So be more than happy to go over this a little more in detail. I won't have a chance to go into this in depth this session, but when we look at framing, we definitely will incorporate a lot of these principles. Again, very standard, same with any other building code requirement. There's standard provisions of using preserved wood or permanent wood foundations. I got to get that out of my head. Stipulations about the depths and how and a lot of details within the standard that we'll go over. There is benefits, obviously, to using PWF, but there's again some other benefits to ICF. You can work on both of those and look at your logistics of how your team is, you're training your team, and your return and investment. And then once you're setting up your foundation walls, there is a prescriptive requirement for the inspection type. So we outlined in session one. And just again, making sure that previous corrections are being dealt with. Your permit package is on site, again, because you want to make sure your team is building off it. Then you want to make sure your inspector has, even if we go fully online and digital, you want to make sure that information is always on site for your team. Specifications for your wood foundations, your ICF and rebar installations are all done prescriptively. Or if you have an engineer involved in either one of those, that are engineering field reports are brought in. Where this fits in for your damp proofing for either foundation materials, and is where inspections may change slightly in the sequencing. You have your radon controls, again, making sure all those perimeters are there, and confirmation what type of backfill, because again, we talked about that could be really problematic as well. This is a benchmark, so once we get at the stage where you're ready to start backfilling, that is a benchmark inspection. So you want to make sure, again, all your previous deficiencies to take care of. If there's any update, something to be done, updated drawings, that those be taken care of, because at this stage, if it's not, then that may be a part where your building official may not feel comfortable moving ahead, especially if there's some outlining major deficiencies that, yeah, we'll deal with that later. I'll get you that paperwork later. That's probably not the best point, especially as you move into completion, and then somebody can't finish off their end of the bargain because they weren't able to see what they need or weren't sent a picture or whatever. So this may be a stop or stop work inspection if you're not careful getting all your stuff in. When in doubt, reach out. There's a lot of great information building up on the city's website, both for planning and for building. And you can go on and find the contact information, book a meeting, read that information, especially those new bulletins that are coming out. And the next section, I mentioned that it won't be a 2-week. This needs to adjust for some of I'm actually starting a new job with building standards, so I'll be actually writing code and updating codes on a national and BC-centric matters. But we will touch on February 12th framing, including, unfortunately, to get into preserved wood foundations very much, but I'd like to touch base on that and how everything ties together, and then how the framing works with the ICF as well. So thank you for those that were able to stick with me. I really appreciate your time. I know it's very valuable, and I apologize for not being able to fit it in, and I wasn't able to show you the 3D working example, but I will jump on to that very first thing as we move into our session 3 on February 12th. We'll go over how we're sitting with the foundation and then starting to apply the framing works on a 3D and start looking at, again, those columns, those decks, and those footing designs to make sure that they're all meeting minimum code requirements. So thank you, and we'll be forwarding the video will be saved of this, and then I'll be updating a few items on the PowerPoint, and I'll be sending those off to Peter probably at the end of this week. So thank you, Peter. Thank you.
Great, thanks everyone. And thanks, Ken, for your presentation. I will just find the link to where the webinars are going to be saved. They'll be up on our website here. Just take me a second to find the link, but I'll stick it in there. And if you end up missing any of the sessions, you can always refer back to them. Along with the recordings, I'm going to also post Ken's presentation so that you can refer to that as well.
Are you able to find it, Peter?
Yeah, I'm just posting it now. It should be up on this page. So
okay, great.
we don't actually have it there yet, but they will be there shortly.
Okay. Just 30 seconds. This is the one of the designs that I've been working on. I showed a little bit this at the workshop. So I'll be drawing the building in different stages and trying to work out things. So as we move through this building, it's a 2-story over. Again, this one shows a half crawl space, half inside, or full basement. But what I'd like to do is, when we look at these type of things and start thinking about the design parameters of the building, I do want to go over this the next session, spend a few minutes going over where we came from, and then, where, pulling the concrete slab back and start looking at, again, double checking the footing design, especially this one in the back. With the red, again, we have, you can see here, looking at this situation, this is where I end up. We have 2 decks and a roof, making sure that we're designing this all and thinking about, frost protection, those type of things. So that's what I was just been working on as we move forward and developing these guides and developing floor plan examples and cross sections and things like that. So have a look at, definitely have a look at the city's webpage, check all those new bulletins out, reach out to the team. I would suggest maybe bringing your team and their team together over the next few months. And as we noted in session 1, don't leave your permit application till the last few weeks. If you're thinking of starting to build early summer, try to get your permit applications in now. Try to be dealt with, because you may need revisions, you may need to work with that, because that created the ice jam last year. Is so many things came in. That was one of the main concerns, is everything came in. And make your application soon. Reach out if you have questions. The team is there to help you out. Thank you very much, and have a great day and the rest of the week.